we are measuring segments. So we're going to start off with measuring on a number line. So we're going to define the distance between 2 points. So the distance between 2 points is the absolute value because distance is always positive. So it's the absolute value of the difference of the 2 coordinates. And I'll just say 2 points. 2 points or 2 coordinates. And that looks like an A, which it's really not. So what does that look like? So let's draw a number line. And then we'll put some points on there. And we'll call this 7, 9, 11, 13, 15, 17, and 19. And then I'm going to put points B here and D here. So we're going to find the distance from B to D. You could either do 9 minus 15 or 15 minus 9. It doesn't matter. But one of those answers is going to give you a negative, and one of those answers is going to give you a positive. So that's why we always do the absolute value. And some new notation for you would be the following. If I wrote BD without anything above it and anything in front of it. So if I just write 2 letters BD, the implication is that I'm asking you to find the distance from B to D. So new notation, find the distance from B to D. And to do that, we're going to use absolute value. So I'm going to take the absolute value of my 2 points. I always like to take the bigger and subtract the smaller. But you could have done 9 minus 15. What is the difference between 15 and 9? 6. And what is the absolute value of 6? 6. What would have been 9 minus 15? Negative 6. And what's the absolute value of negative 6? 6. So it didn't matter which one you chose. I just always like to do bigger minus smaller. And you can count on your number line. The problem with this number line, if I tried to count hash marks on this number line, if I counted 1, 2, 3, and you had a multiple choice question, I'll bet you one of the answer choices would be a distance of 3, because you're just counting on here and not paying attention to the fact that the scale is going by what? 2s. So if you're going to bunny hop count by 2s then, because that's what the scale is going by. So you could do 2, 4, 6. They are a distance of 6 away, right? So that's all you're going to do for that one. Then we have one postulate we're going to look at today, and that is the segments. So this should go on a flashcard. How many of you made flashcards yesterday? 1, 2, good. I want all of you making flashcards, right? Because you're getting a couple more things today. So your segment addition postulate says the following. If 3 points A, B, and C are collinear and some of these postulates can get real wordy, so don't get wrapped up in it. I'm going to show you a picture that will explain everything. And B is between A and C. Then AB plus BC is equal to AC. So that doesn't mean a whole lot right now until I give you a picture that demonstrates what in the world are they talking about. So we're going to draw a picture. So you ready? All right, so, and oftentimes they're going to tell you something and you have to try to draw the picture from what they're telling you. So they've got 3 points, A, B, and C. They're collinear. What does that mean? Collinear. They're all on the same line. Good. So we're going to draw those points, A, B, and C, all on the same line. And then specifically, because I could put them in whatever order I wanted to, but specifically it says that B is between A and C. So we're going to draw a line. I'm going to put 3 points on it. I purposely put this point not in the middle because I don't know that B is directly center. And they're going to label those points A, B, and C. Could I have written C, B, and A? Yes, as long as B is in between A and C. And so notice what this is saying. It says, if that's true, then AB plus BC equals AC. This is that new notation. It says the distance from A to B plus the distance from B to C is equal to the distance from A to C. So they're saying the distance from A to B, so this distance here, plus the distance, so let me put this one in red, plus the distance from B to C, I'm going to put that one in green, represents the distance from A all the way to C. That makes sense, right? The two smaller pieces add up to give you that overall large piece. You're going to set up some problems today regarding this equation. You're going to find the two smaller pieces, add them together, and set them equal to the larger piece. There could be algebra involved in this, okay? So what if, so let's do an example. So for example, what if AB equaled 5 and BC equaled 4? So according to this, if AB were 5 and BC were 4, what do you conclude? So wouldn't we take our formula and say, okay, AB plus BC is equal to AC, right? The two smaller pieces added together equals the bigger piece. Well, we know that AB is 5, plus we know that BC is 4, and that's supposed to equal the distance from A to C. What's the distance from A to C? 9. So 9 is equal to the distance from A to C. So that's just a super simple one for that. We're going to get into something a little bit more difficult. Are you ready? Here we go. So let me, there we go. So we added another one. What if, okay, so let's look at example 1. So in example 1, you've got the following picture. And then they've told you and then in addition to this, they've told you that JL is equal to 120. The question is, all right, so the question is, as I put my hand on the thing, what is, or what are JK and KL? So that's that new notation again. They're asking you for JK, what are they asking you? What's that new notation mean, JK? What's the distance from J to K? And they're also asking what's the distance from K to L. So we have to find, we know that the whole length is 120, right? So if I were you in the picture, I would immediately label that 120 goes from here all the way to here. So you're going to set up your equation to solve by taking the segment addition postulate. We're going to use this postulate a lot. You're going to take the two smaller pieces and do what with them? Visually, what did the two smaller pieces do versus the bigger? You add them together and you set them what? Equal to the larger piece, not 0, but the larger piece, which is 120, right? So we're going to take the two smaller pieces. Segment addition postulate says, so step 1, it says that JK plus KL, okay, so we're going to take 4x plus 6 and add to that the 7x plus 5, or 15, sorry, equals what? Yep, the whole distance, JL is 120. So now all it is algebra. How do we solve? In your groups, I want you to go ahead and solve. Do that. So you're going to underline these two and double underline these two. So what is 4x and 7x? 11x. And what is 6 and 15? 21. Equals that 120. Now go ahead and finish solving. So you're going to solve in your groups, and I'm going to just quietly solve it up here. So you finish up in your groups. Show your work to both sides. If your work doesn't look like what mine's up here, you're going to end up losing points with me. So show the work to both sides. So the last thing you do is divide. So share amongst your table members what they got. So everybody should get the same value for x. Do you agree? So what do we all get? 9 is correct. Does that answer the question? The question is looking for what? You got to plug it in. Plug it in, right? So the question says, what is JK? Well, JK is equal to 4x plus 6, right? So we're going to plug in 9 for that x. Right? So what's 4 times 9? So 36 plus 6 equals 42. So there's one answer. And then KL is 7x plus 15. So you've got 7, your x is the 9 that we came up with, plus the 15. So what's 7 times 9? 63 plus 15 78. And then how could I check my answers to see if they're correct? Add these together, because their total should equal what? And does it? 8 plus 2 is 10, carry the 1. 7 plus 4 is 11, plus 1 is 12. So it does equal 120, which is that whole length from J to L. So therefore, a triangle of dots is your therefore. So therefore, JK is 42 units, and KL is 78. So just because we solve for X doesn't mean we answered the question. Okay, so then, I think I'm going to go ahead and, do I want to stop here? Let's talk about congruent segments. We'll just do a couple of definitions, and then we're going to start on our homework. So I'd like you to write down the definition for congruent segments. What do you think it is? The same. So they would be segments with the same length, right? And then the other one we need to talk about is what's a segment bisector. So a segment bisector what do you think something that is a segment bisector does? Bisect. What does bi mean? Two. So what does a segment bisector do? It cuts something in two. It's like a knife that cuts something in two. There's a lot of things that can be a segment bisector. A point can be a segment bisector. A line can be a segment bisector. A line segment can be a segment bisector. So it is a point, line, or ray, or another segment that intersects a segment at its midpoint. And so it might look like this. So here's a segment, and then maybe you have this other, I don't know, line, point, ray, something that's coming through here. And you have this point B, A, and C. Tick marks imply congruency. So because segment AB and segment BC have these two little tick marks on there, it's telling you that AB and BC are congruent. And what's the midpoint of segment BC of segment AC? What's the midpoint? The very center point, B. So B is your midpoint. So right here, B is the midpoint. And in order to find a midpoint, so let's just say that A was the number 10 and C was the number 12. What number is in between 10 and 12? 11. So here's your formula for a midpoint if it wasn't that simple. It might not be that simple. So here's your midpoint formula from algebra and middle school. You're going to take your 2 points, so we'll call those 2 points x sub 1 and x sub 2. You would add those points together and divide by 2. So if I took 10 and added it to 12, what's 10 plus 12? 22. What's 22 divided by 2? 11. Isn't that the midpoint that you came up with logic reasoning? So this formula right here will get you that midpoint.